Yeah. Oh, damn. Sorry, I hope. Yeah. Oh,
Yeah.
damn. Sorry, I hope.
Yeah.
So yeah, welcome back. This is day 3 of grinding Leetcode. Yeah, everything seems to be in order, so just let's begin. We still continue for where we left off. We had a viewer yesterday, Cheesefest, who helped me with recommendations towards how I can improve. I will just go back to Leetcode right now and try. I will skip the hard one because I realized I kind of understand how you're supposed to do it now that you use next element and previous element, but I'm not that familiar with monotonic stacks yet, so I will come back to it later. I think I'm just gonna become more proficient at easy and medium before continuing. So yeah, I don't remember what the issue here was. Yeah, I was doing it as dynamic programming, which was incorrect in a sense. It wasn't incorrect way. It was my implementation that was incorrect. But I also looked at the solution. I just don't remember the solution that well. So yeah, because we can already see this is have a really high runtime. I would say so. Yeah, it's pretty damn high. Or wait a second, square root. Ah. Yeah. To be fair, this is actually interesting. It's only it's not that significant. Okay, never mind. The square divide by square this time. Never mind. Can you think of a better way? Boom boom. Use pruning to generate invalid strings. Oh, I remember you need to use backtracking on this. I'm not that familiar with how backtracking works yet. I haven't arrived there yet. I might skip it for now, but I think I remember how you would do it. I think I will wait for. I remember car fleets though. What was the issue with that? I remember I didn't get it, but I don't remember what the issue was. Oh, wait a second. It was depending on the car fleets. I have in my mind somewhat of solution. I think I would skip this too just to. Oh, that wasn't a good point. Just to. I don't think it's fair that I know the answer to it, so I go 2 pointers, which is one of my. I wouldn't say favorites, but it's I learned it really late, and I realized I actually enjoy this. It was yeah, it was fascinating since I don't know why, if I've had it before, I just can't remember ever learning it. I saw something you had to remove all special characters. Yeah, it's string reads same forward and backward. It is also case sensitive and ignores all non-alphanumeric characters. So yeah, I saw it because it was kind of cheating. Because they used is a re-sub. I think it's import re and s equals to re-sub, and then all the characters. I don't remember all of them. This is cheating, but I will do it just because I I need to like learn it more properly, and I don't have the memory for it. That's not it. Yeah, resub alphanumeric. Oh, it's which one I want to keep. Mm-hmm. Why is N not? Oh no, because yeah, I understand. And it's case sensitive regardless, so okay, you could join on char for char and text it. What's the runtime on this though? I like this more though. So it's A to C, and 0 to 9. This is something I would never remember. Do I feel bad for doing it? Possibly, but not that. Okay, it's R, and then I will forget this one, and it's subbing with empty string and taking text. Yeah, okay, the taken as, I mean. So, and it's also case insensitive. Okay, so it doesn't matter. Can I do lower? Just testing if like it worked. Yeah, it worked. And now, yeah, well, 2 pointers. Is that the most efficient way? The runtime would be big O of n divided by 2, wouldn't it? Or is it just n? There has to be like smarter ways of doing it, but since it's I'll do it like the intuitive way, you could say. So we have pointer 1 left equals 0 and pointer right equals to len of s minus 1. So while L is less than R, let me see, would I need to check if L less than R and continue? Let's see. How would be the smart way of doing it? Because intuitively I just kind of just want to splice it in half and then compare them to each other, like reverse the one. Okay, the reverse have a runtime of n log of n, doesn't it? Runtime of reversing of n. Yeah, it's O of n, and I don't want that. This should be a pretty easy way of doing it. But yeah, back to the question. So essentially, the 2 pointers. One is pointing at. Maybe it's actually while L is less than R, and S of L equals to S of R. Then we would increment it up, and this will decrease. And maybe it's not a while, maybe it's what if I do it as an if sentence and else is return false, and if it for some reason makes true everything, it should return true. I just want to test it. I know there's some. Oh no, it was actually correct. I'm like just curious if, because I didn't account for odd and even numbers, but yeah, it worked. Yeah, great, it worked. Yeah, it's this is pretty simple. What I'm doing is essentially, because of the question and the constraints, you have to remove all non-alphanumeric numbers, meaning the alphabet and the numbers. Pretty straightforward. And as it's case insensitive, I could also do like either like a lowercase number, words, no, letters, or capital letters. It wouldn't matter in this case. And then I have a 2-pointer system. Yeah, wasn't easy regardless, so it was not that impressive. We can go to the next one. To sum. Oh, I like. No, it's not two integer sum. Okay, I did not actually see what's here. So, given an array of integer numbers that's sorted in non-decreasing order, return the indices one indexed of two numbers, index 1 and index 2, such that add up to a given target and index is less than also cannot be equal. Therefore, you may not use the same element twice. There will also be exactly one valid solution. Your solution use O of an additional space. Seem pretty straightforward. I'm just like, and it's non-decreasing. Is there a case where and will give another? Cannot be equal, yeah, therefore you may not use the same element twice. There will always be exactly one solution useful. Okay, we can just pretty straightforward. Left pointer is 0, and it's len of numbers. So while L is less than R, okay, so if is it equals to? Okay, probably equals to. I could I just start it at 1? No. Okay, it wouldn't matter. It's not important. Okay, so if what numbers of L plus numbers of R equals to targets, we would return L plus 1 and R plus 1. If numbers L, yeah, I just copied it, so I don't need to write it so many times. I'm doing one more time. Okay, let's say it's less than. Since it's less, we need to increase, so the L has to increase. L plus equals 1, and else it's R minus 1. And we know for a fact there are exactly one valid solution. And when Yeah, to be fair, do I need a return? Wouldn't this like work? No, it wouldn't work. Pardon me? Yeah, this worked just fine. Yeah. Okay, that was pretty straightforward too. It's just implementing two-pointer. Threesome. Now we get into something juicy. I did not see what happened there. I saw that. Given array nums, threesome I would assume is a reference to twosome, which is like the standard two-pointer question. So given an integer array nums, return all triplets, where, okay, the instances are all distinct. Should not contain any duplicate triplets. You may return the output and the triplets in any order. So I need every one of them. Okay, this is I'm trying to figure out like how I would do this like optimally. And it is not in any specific order. I might want to sort it. And it's equals to 0. Okay, never mind. Like, how would I go with this? And if it's nothing, it just returns. So from this, they're all distinct from each other. Yeah, I don't think but it's a two-pointer question. That's why, like, that's I know it's kind of cheating, since I know it was supposed this is within a specific realm. It has like backfired a lot of times when I'm not sure of it. So yeah. Are all distinct. The output should not contain any duplicate triplets. You may return the output of triplets in any order. Order. I'm like just thinking, like just thinking out loud. I think like if this was a real test, I would just do it like by intuition. But since I have time to explain and think, I would just look at. I prefer to like get somewhat optimal answers from the get-go, because often or not it's not that much more complicated than just doing the brute force way, because I think the brute force way would be to look at no, that might actually not be the brute force way. It's a brute force way, but it's actually a really bad way. And I'm thinking, like, would sorting help me at all? Okay, so the brute force way I was thinking of is, for instance, taking the first number, we iterate through each number, and then we use the two-pointer system on the rest. And the target would be the index of, the value of whatever number we are on. I really don't like it. Recommend you should aim for. Okay, that might actually be true though. Dude, I think. Okay, I will just do the brute force one. For num and nums. I'm just gonna think for a while, like, what would be the best way of doing it. Do I need to enumerate? Because I was thinking of splicing. I might actually do it. And okay, in index and enumerate nums. Okay. Target equals num. And the list, okay, temp list would be nums 0 to index plus nums of index. Out of curiosity, I just want to ensure this is correct. So nums, okay. Why did print out? For the first one, it should have been incorrect. This might be correct then. No, it's not correct. Or is it? It's just the first two are incorrect, and that's confusing me. Why this happens like this. So for the first, because like the reason I'm doing it this way is I need to learn splicing properly, and I think this is a good way of like just doing it. Okay, let's just zero to 0. Shouldn't this just not return anything? Why is this shown? Do I do something weird here? Why does it print out this? This is what's confusing me. This is what's confusing me of. And print would be this. Maybe I should ignore it, but why does it print out this? This is correct, so I'm actually correct on this. At least not taking into account. Okay, if I don't print it, does it like also come out as print? Yeah, it does. So I can ignore that and just like. So the three first are not, okay, this is correct. Then we remove the 0, yeah. Then we remove the 1, yeah, looks correct. So L equals 0, R equals. So now I'm just doing the standard two-sum algorithm, which has a runtime of it's not sorted. Should have sorted at the beginning. Yeah. Sort. Because I don't. because it will be in the correct, it will be a non-decreasing order from the get-go of. Why is the nums sorted? Shouldn't it be sorted by? Okay. I didn't need to do it beforehand, but still. And this didn't work even. It's like nums equals sorted nums. Does this work? No, why can't I sort it? All distinct outputs should not contain any duplicate triplets. You may return the output and the triplets in any order. Why can't I sort it? This is almost embarrassing. Like, I know this part works. It is sorted. I'm stupid. I'm so stupid. I'm so fucking stupid. Never mind. It works just as intended. I just saw 4 and be like, no, that's not correct, but it's -4. So yeah, the first one is yeah. I see it now. Okay, anyways, then this is correct. And like I said, just standard len of temp list -1. While L is less than R. Do I need, I think if L less than R and L and temp list of L plus temp list of R, pardon me, R equals to target, and we need also an answer list. And append to be fair, there might be more than one duplicate numbers. Okay, append. It should be on target, temp list L, and temp list R. So we can copy this. If it's less than target, then L plus equals 1, else R minus equals 1. Yep, that seems good. And then return ans. Oh. Well, yeah, runtime is horrible. Which I assumed, to be fair. I wasn't thinking this was an awful way of doing it. Oh, because... Yeah, I see the problem, because it just stops here. And the issue is... Would it be break? Break? Like, would this work? Yeah, it didn't pass, but it worked. Shouldn't it go back to this then? Oh, target should be the negative of this, shouldn't it? Minus them. It worked for this one apparently, because you didn't get anything, never mind. No, I think it actually should be the same. Well, wait, the second one? Why is this incorrect? It should be minus, yeah. Because this would be 5. No, I think this is correct though. Let me see, what's the issue here? The problem is that I'm not getting anything, so it doesn't matter, even though this should probably be minus, but still. Okay, if I don't have the break here, what will happen? I think there will be a runtime error. To be fair, isn't this correct? In any order. Yeah, okay. So these two are the same, so I would be a set. However, that is also the same as this. Okay, I think I have a solution in terms of how I can do it, just like making the list smaller and smaller until it's not like feasible anymore. I just don't like that way, I think. I would try it for the heck of it. I'm just like trying to like visualize it in my mind. So yeah, maybe I'll do that actually. I'll try this and see if this works. Yeah, this worked. I don't particularly... Oh, no, it didn't work. And I can return as a set. When just solve it pretty simply. No, it wouldn't. I can't do that, apparently. Can I do it like this? It's probably not append then, or... And to set Python. The add function. It's not a list. Because I don't want to do this. I think that's stupid. Not this, like I meant like I don't need to do it because I shouldn't list tuple. This is this is That's a very fucked up way of doing it. Okay, what's the time complexity? I want it lower. Can't I get it lower? NumPy. Maybe NumPy is the solution. Unique. Apparently, okay, to be fair, my answer shouldn't be that long even. Why is this? Oh, this is also another question. Yeah. It's worked on for all these cases, but it didn't work for this case because obviously these are the same. And I completely agree. Like okay, I think like this solves it by using this. I really dislike this. What? Tuple has no... Pardon? So this doesn't even work. I can use a lambda expression. I really dislike this. What? Where do I use L sort? Okay, if I don't do this. Okay, if I don't sort it. Yeah, fine. Because I was like just gonna do this. I'm not gonna do that. Okay, I think. F not an ants. Yeah. No. Why wasn't I able to find it? It's probably because of like the way I was. Dude, I gonna look at the solution. I know it's cheating. I just want to figure out the yeah. I was thinking of a hash map. I just didn't think I would need it. I want the 2.2 version. Okay, yeah. Yeah, it worked, but it doesn't matter. If a is bigger than 0, break would go to the next, right? Yeah, I didn't understand this one. I was thinking this would actually work. Yeah, it worked. Okay, so I was thinking correctly. I think mine is slightly slower, but it's not. I think it's still the same runtime, isn't it? Oh, now I'm curious, like, can ChatGPT ever figure out the runtime? Yeah, this is what I was worried about. Okay, yeah, forgot that was the case. It's plus, it's not, so it's, yeah. Fuck yeah, I did it. Trapping rainwater, this is a hard one apparently. And this I kinda wanna do. After this I'm just gonna add everything to my Leetcode just to like have it. Repetitive integers height. All non-negative integers which represent. Oh, why are they so repetitive? Okay, each value represents the height of the bar which has width. I have a suggestion for it. It's a variation of. I don't know what I did here. I'm not gonna bother looking at it. Okay, I have a way, like the way I'm gonna explain it. Okay, I can try to explain like the way I was thinking. I was like, oh, it's a 2-pointer, but it doesn't start. It starts like, I don't know if it's like so fast. It's more similar to so fast, I would reckon. So it starts at the first index, that would be left, and it will check like, oh, in this case we add 0 to left, and then it will look at the next element as it's higher than. So as long as the next element's higher, left will become the higher element. And then if it's not higher, it will start somewhat of calculation to. Yeah, it will. I need to verbalize them better. It will start a calculation, like for instance if we were here, it would say, oh, this is lower than 3, this is lower than 3, this is lower than 3, this is equal to 3. So we would know this inside of here are water. And then we will calculate water by taking a splice of this. And after it's done that, it will go back. Left will be this one. And I think this is like a correct way of thinking. Why did my phone buzz? I will try this out. Okay. I'll try this out to see while L less than equals to len of height minus 1, 0. So yeah, L is set to 0. And then it would look at the next element. If height of L plus 1 is higher than L equals to height of else it's not higher, it's equal, higher, equal to. Do I need to enumerate? Because that's the value, not yeah, pardon, I need to enumerate. I need to find a way to enumerate this shit. Okay, if height is larger equal to L will become that one. So it's not L. So one L is not the L, it's pointing to the value, while the second is the ind. So if the index and height of the x is height equal to val equals to height. Else and then we'll calculate that, but regardless, else okay, let's see. So now I found something. So now over here it will be less. While so well is less than equal to val. Well, it's not. It will just continue. Okay. L val or L end. So okay. Boom. And this would be incorrect. I don't care right now because I'm gonna fix it afterwards. Okay, so while now we set R as a temp val. No, I don't need R equals to L end plus 1. If R end is less than equals to L val, so apparently I don't need to so as long as less, R n plus equals 1. So since it's not, now we do the calculation part. So we have R in, it's most likely, for instance, in this case, it would be print R end, L end, and L val. Height is L in. Yeah, most likely but it doesn't. Yeah, I see it's gonna be. I just want to see it work. Break. Would like this solid. Break, break. If an L in equals 1. While height less than equals to L val, like, does it even like get over here? Yes, it does. Its first value and the index. Yeah, and that's correct. Else if height is larger than, okay, but else means it's less. This is like a so it is one of those. I just want to see like how they use a stack and middle prefix. Yeah, how are you supposed to use a 2 pointer on this? But yeah. I think my way would have worked, but yeah. I remember this pretty. I think I actually want to do some of those. Before I do that, I want to since I haven't done this, I'm just filling out so I in case I haven't done this, I will just add them to the. I sold this, nice. I have not sold a min stack. Apparently. Right, I have not eval of. This is such a bad call. I remember I was so mad at myself for that. Right, then we have this, and daily temperature I haven't done either. Then we're gonna go to dump stacks, now it's 2 pointers. Oh. Haven't I done it? This worked, yeah. Mm-hmm. Yeah, for... Why did this work and not... Okay, oh... Weird. Oh, that 2 point is... Nah, yeah. I've solved this before. Downwards threesome. I just did. Yeah. Then it was container with the most water. I think it's the next. Oh no. When did I do this? Yeah, when did I do with the most water? Container with most. Did I just do it and I not even remember? I think I did it yesterday. It was pretty simple, to be fair. Yeah, I solved it before. Never mind. And then it was array and hashing. This isn't correct. I haven't done this. Or did I? I think I ended up doing it in the end. Yeah, I did it. I'm probably sure, pretty sure I've done it like before. I would assume like the majority of these I've done before. Yeah, sold, 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 not sold. Not sold. Oh, really? Sold, sold, sold. Apparently doesn't work, I don't care. And top K elements. Checking my Leetcode stats. like how like out of curiosity, how difficult are like the daily this looks like something I can do. About the because you're running out of time. Array of code of length n and k. Every number all simultaneously. Replace with the sum of the next k numbers. Replace the if number. Okay, yeah. Previous k numbers. Okay, it's circular. Let me see how is the easiest way to do it. Yeah, like it doesn't matter like what's previous or. I can do, okay, let's see what's, don't want to do that way. Okay, for num and code have k equals to 0. I'd replace simultaneous. So it's not a for loop yet. Times and this is incorrect regardless. Shouldn't matter. And append 0. K is larger than 0. And else we have this too. It's bigger than k, so it's next. Like the easiest way. I think like some mood loose shit will work. Because I'll get 3 next, so okay, for E in the range of k. Some, yeah, possum equals to 0. So pass sum plus equals to code of I modulo k and append sum. Else it's exactly the same, just negative. Neg f minus k minus k neg, so this is pass sum return ants. Why is this incorrect? How did I do this? It's like k minus 1. Plus 1? Yeah, it's plus 1. Shouldn't it? Okay, I think it's actually this. What I don't understand is why this, because k is larger than, so for k in range it should be this, and modulo oh, it doesn't do that. No, it's not. Okay, e plus okay, like, do I need to do it? Okay, I can do it just to like the Leetcode. For e in plus index. Well, is -1. It's simply too much. What? Why is this correct? Okay, yeah, because it's 0. Next, K numbers. I think, okay. Save 3, 4. Because this confuses me so much. Why? Yeah, it is -K. Seven, 3, 4, 7. I could have used sliding window. I'm a dumb fuck. Yeah, no one's watching. Yeah, okay, this is so much better. Code. Yeah, I think I will take a slight break. Just on time. Oh, that looks like a par. I will mute. Just on time. I'm back. Hey, I'm back. How long did it? Wasn't that long. I thought I've been streaming for longer. I'm back. Where were I? Sorry. Yeah. I notice I'm slightly tired right now, so I will, yeah, probably just take it easy. Oh, I don't know, okay, you are in your prices. Okay. And the sliding window is apparently what I should do. This is the easy one. Why is my brain struggling to think? I would just need to watch some videos. I haven't posted in a while. Should I just learn the Python? I remember this guy. It was so fun. Oh shit, sorry. It was so fun because like he was cleaning all his what was the OCD like out of the sudden I wasn't prepared. I was like listening to something else, but like oh.
For me? Can you like calm me down before we start? I'm nervous. I haven't coded in a long. It's ever since I failed my last Citadel interview. Alright, bro. If I fail tomorrow, I will be calling you.
Okay, pause. This is FAANG. He's a college student who recently finished an internship at Meta, and today we are doing a mock Google coding interview. The day after we conducted this, he actually had an interview at Bloomberg for a new grad position. But if you're new to the channel, I'm Leetcode. I started working at Google as a software engineer about a year ago. My channel is all about helping people prepare for coding interviews. By the way, if you're preparing for coding interviews, definitely check out leetcode.io. It's a site that I created to help you ace your next coding interview. We also have courses for algorithms and system design, and actually the question I'll be asking FAANG is from this list. Anyways, moving on. With this mock interview, I'm trying to emulate how a real Google coding interview goes. So this is meant to be as realistic as possible. I'm going to give FAANG a data structures and algorithms related if he wants to get a high hit, what he could have done better. I'm going to give him realistic feedback on how to let's get started.
Okay, so I'm going to start the timer right now.
Okay.
Okay, so this is the question. I want you to design a class that supports these three operations. So the first operation is inserting a value. And you can assume that there's no duplicates allowed. So you might be given a duplicate, but you don't want to actually store the duplicate. The second thing is removing a value from this class. And where it gets interesting is I want you to be able to get a random value that is already inserted. And among the values that are inserted, I want it to be of equal probability. So just these three operations.
Okay. Okay. All right. So let me just repeat the question back to you to make sure I understand. From what I understand, I have to create a class that essentially has three functions. One is to insert an element, second one is to remove an element, and the third one is to get a random value that is currently in the class. Is that correct?
Yep, that's exactly right.
Nice. Are these values like integers or strings or like animals? Like, are these specific something?
Yeah, you can assume that they're integers.
Okay. All right. Great. So then let me ask you this question. Are there going to be a lot of elements we're inserting, or is it just going to be a certain amount?
You can assume that it's like a reasonable amount, like less, maybe like in the terms of millions, but you shouldn't run into like any limitations like with memory or anything like that.
Okay. So let me ask you another question. Is there going to be more insertions done, or more removals done, or more get randoms done?
You can assume that they'll be like of equal quantity, like equal proportion.
Okay. Thank you very much. I'm going to ask you one final question before I start coding. Can I code in Python?
Sure.
Okay, here we go. So the first thing I'm going to do is create a class. Wow, there's auto capitalization in this Google Doc. I don't know why you guys perform the interviews in Google Docs. I think it's very stupid, but... Alright, so class, okay, so let's just call this a store. Class store. And we're going to start with the constructor. Is there a way to turn off this auto capitalization for? This is really annoying me.
Ignore it. Yeah, you can just pretend, like we can ignore the capitalization, you can just assume it's correct.
Hey, try to ignore it. I'm just going to say it's not very inclusive of you because I have OCD and this is pissing me off. Alright, so constructor init, and this will be the constructor. So, here we go. What are the variables?
I've seen this, so I have to
inserting values and removing values, so we need a data structure to store these things. So let's think about
I hope that you enjoy the Google coding interview. Okay, David, so are you ready to start the interview?
I think I am, yeah, we'll see.
All right, great. So I'm going to press start on a 45-minute timer now, and let's begin. So if you were to take out your phone right now, either an iPhone or an Android phone, and you were to look at your keypad on your phone, you would likely see something like this. You would likely see something like this, where you've got the numbers, right, the digits, 1, 2, 3, all the way to 9. But you would see, like, on the digits, you would see letters, right? So, like, under the 2, you would likely see ABC. Under the 3, you would likely see D, E, F. And this is something that was like really common in old phones. They still have it in modern phones, but it was really common in old phones. And the reason it was common is because it allowed you to have phone numbers that kind of read like English. So I don't know if you've ever heard of the company like 1-800-Flowers. I'll copy and paste it here. 1-800-Flowers. It's the name of a company, but it's also a phone number. And this phone number is actually, let me copy it here. This phone number is actually 1-800-356-9377, but it kind of maps to 1-800-Flowers. Does that make sense?
Yeah, that makes sense to me, I think.
Yeah. So the point that I'm trying to get across here is that if you've got a keypad like this with digits, numbers, phone numbers, can represent different words. I'll give you one more example. Like this phone number here can represent either Clement or Clemdot, okay, or any other, like there are a bunch of other combinations of words. Now I want you to write an algorithm or a function that is going to take two inputs. It's going to take a phone number, which is going to be a stringified phone number, as well as a list of words, okay? So I'll give you a sample input right now. Sample input would be these two things. You've got a phone number, you've got a list of words, and I want your algorithm to determine which of the words in this list of words are contained in this phone numbers. Kind of like the word flowers here is contained in this phone number. And so for this particular input, you would return something like this, because these, I'll put output here, because these words here happen to be in this phone number.
So I'm looking for ones that occur anywhere in the phone number, right?
Anywhere
So
in the
any,
phone number.
Any substring, like any continuous range?
Yes, continuous is the keyword there.
I see. Interesting. Okay, so I guess maybe first it might be helpful for me to do some simplifications
Okay.
of the problem a bit. So yeah, okay. So for these words, if we just want to see if some word corresponds to like some number, it's probably easier if I replace each letter with whatever number it would correspond to, right? So in the first instance, like 366 could be a bunch of things, but it might be easier, like if I'm looking for foo, for instance, foo would be, well, it'd be 366. So instead of looking for these words, it might be easier if for each word I have, so like for foo, I could turn it into like 366.
Yep.
Now I want to see, does 366 occur anywhere in the, like as any substring in this? So that might be helpful.
Okay.
And then I can do this for each word. So for each word in the order size of input, then I can look through each of those. Yeah, so on one hand, it seems like maybe it's possible to do some Aho-Crossic sort of thing here, but that might be a bit unnecessary. I guess for like one question that I'm going to ask is the phone number any specific length? Is the phone number might it be like really long, or can I assume the phone number is just like the length of a normal phone number, like 7 digits or something?
You can say that the phone number can be of any length, so it's effectively like any continuous amount of digits. But don't worry too much about the fact that it might be past some gigantic number. So I guess my point is, it's not necessarily 7 numbers. It could be, like 15 numbers or something like that.
Sure.
But don't worry about too large of inputs.
So, like one solution path that I can go down would be something where the final runtime would be order phone number length squared. That would be one solution path that I might be able to use. And the idea behind that would be I can find some representation for every continuous range of this phone number. So if you consider every start point and every end point of the phone number, you'll have some big value. But what I can think about is like I can compress that value into some other value where if some word is also equal to that value, there's a very good chance those are the same. And that's a thing called string hashing. So I guess I'll get there if this would be a solution that would be helpful, but it's spelled length, GTH. So yeah, so that's one thing that I could try. Another thing might be if all of my words are short, if I know all of my words are like some relatively small length, then I can only look at the substrings that are of that length. So if I know maybe all of the words aren't super long, then I can check only substrings of that length. So that would be order like number of different word lengths times the length of the phone number.
So let's assume that for the words, they are of any length between 1, so they can't be empty, between 1 and the length of the phone number.
Okay, so yes, that's a good thing to keep in mind. So I guess that means this solution wouldn't be very helpful at all because it would pretty much just be the same as this top solution. All right, so then, yeah, I guess it might be interesting to consider what if we tried some Aho-Crossic here. So basically, we can imagine, let's say I have some try basically, and the try consists of all of these words.
Okay.
Then what I want to find out basically is for like for each prefix, I want to see for some suffix of that prefix, what's like the longest suffix that exists as some path in the try.
Okay.
And then that'll have like a link back to, well, the details I guess are a little complicated, but we'll be able to see like where this goes in the try. And then based on like where that goes, we can take several steps up and like repeatedly look at that, and then we can mark all of the different words that we see there. So yeah, so I guess basically the idea is like one thing that I might consider for the solution path is maybe I'll build some try of all of the words. And then after that, I'll have like some links for each node in the try. Or I guess there are only 10 digits, right? So I want a 26 links, so 10 links. For like which try node you reach after each step, or after like reading every next possible input.
And I guess, David, just to cut you off here, when you say you're going to have a try of all the words, will you be putting the words in the try as strings, so this current format, or as digit strings?
I'll do it as digit strings. So basically, I'll convert all of these words into digit strings, and then at
So
the
what you
end,
had
in
done
order
down
to
here.
validate some, yeah. At the end, I'll have just like a bunch of digit strings, and then at the end, I can just say if some word matches, I can just check does that digit string match as well.
Gotcha. Okay.
Yeah. Okay. So maybe it might be helpful for me to draw an example for myself, just to kind of remind, because it's been a while since I've coded autocrossic myself.
Okay. By the way, I'm not sure what that is.
What it
so
is,
if you wanted to explain to me what the Aho Classic is.
Yeah. Okay.
I understand what you said with the slide, but I'm not sure what that like word is or name for something is.
Okay. Yeah. So like well, I can explain the general idea. I can definitely, so like if the solution path you're looking for is n squared, I can definitely go down the n squared route. The thing with
Atera is the IT pain.
I didn't want to watch more because he was on another level than where I am, so...
What's up, everybody? How's it going? This is a Google coding interview with a college student. I paired up with Tim. You may know him from the 45-minute timer. Now, awesome. All right, so Tim, when we tried
I hate
to
this.
get this to happen, this mock coding interview, we naturally had to put something on the calendar, right? We had to find a time that worked for both of us and give ourselves 45 minutes or an hour to make sure that we had enough time to record. So I want you to write an algorithm that is going to basically take two people's calendars, you can imagine Google Calendars, and it's going to basically return free slots of time during which these two people could have a meeting. Now, it's going to base of 2 and 3. Well, yeah, give our example of...
The amount of time you gave me for a meeting is within the bounds you gave me.
What do you mean by that?
So, for example, say you said, like, you know, person 1 says they have a meeting, like, they only want to book meetings from 9 a.m., so in this case, I guess we'll say, 20 was at 8 p.m.,
Yep.
then all the meetings you give me will be within those bounds, right? There'll
Yes.
be no meeting that starts at, like, 8:30 or 8:45 or something.
Yes.
And they'll be all, what you assume, all valid input, right? And these are, okay, so these are strings, that's interesting as well, okay.
Yep. They're all valid inputs, they're all strings, and they're all in military time. So,
Yes.
3 p.m. is 50.
And so it looks like these are sorted right now. I'm going to assume they're not necessarily sorted.
No, you actually can assume that they are sorted. You can almost imagine that, like when you open your Google Calendar, you kind of see the meeting.
To 11, from 11:30 to 12:30, right? Like that would be, I know this says 30, but that would be valid, 11:30 to 12:30.
11:30 to 12:30 would indeed be a valid block during which you could schedule a 30-minute meeting. But because at the top here you have this person, or in this case it's me, who has a 12 p.m. meeting, as you can see in the answer, the block that we would be able to schedule would only be until 12.
Okay, so obviously that makes sense. But yeah, I was just trying to figure out, if the meeting ends at 11:30, the next meeting can start at 11:30, and then if the meeting ends at 12:30, then so I should start this case when I'm actively, or is gonna, if I get this next time list, it's here 4:30. Okay, so there's no time here. So now,
Coding interviews are hard. So much so that there's nerds out there solving hundreds of Leetcode problems just to get ahead. But is that really necessary? Do we really live in a world where you need to cherry pick up a 3-dimensional dynamic programming problem just to get a job? I don't think so. Yes, technically anything can come up in an interview, but I think there's a smarter way to prepare. Why not prioritize the concepts that are easiest to learn, but also are most likely to come up in interviews? Well, because most people don't know what those are. But with my background, I think I do. Arrays are the first data structure that we all learn about, and that's because they're simple. But there's surprisingly a lot of non-trivial algorithms relevant to arrays. I'm not just talking about binary search and sorting, but also two-pointers, the sliding window. And if we want to get fancy, we can even do some pre-processing by computing the prefix sums of an array to solve certain problems more efficiently. And the good thing is, most of these algorithms are actually not very complicated once you understand them. But if I were you, I wouldn't just understand them. I would get so good at them that solving a simple binary search or a sliding window problem feels as easy as writing a for loop, even if that means you have to go back and re-solve the same easy problem multiple times. A lot of people will struggle with more difficult problems, and that's because they don't have a really good grasp of the basics. And actually, arrays are so all-encompassing that many other patterns can also be applied to them, like stacks, greedy algorithms, and of course everyone's favorite, dynamic programming. Another broad thing I do. Arrays are the first data structure that we all learn about, and that's because they're simple, but there's surprisingly a lot of non-trivial algorithms relevant to arrays. I'm not just talking about binary search and sorting, but also two-pointers, the sliding window. And if we want to get fancy, we can even do some pre-processing by computing the prefix sums of an array to solve certain problems more efficiently. And the good thing is, most of these algorithms are actually not very complicated once you understand them. But if I were you, I wouldn't just understand them. I would get so good at them that solving a simple binary search or a sliding window problem feels as easy as writing a for loop, even if that means you have to go back and re-solve the same easy problem multiple times. A lot of people will struggle with more difficult problems, and that's because they don't have a really good grasp of the basics. And actually, arrays are so all-encompassing that many other patterns can also be applied to them, like stacks, greedy algorithms, and of course everyone's favorite, dynamic programming. Another broad concept is recursive decision decision trees. You might be thinking, doesn't the specific pattern actually matter? Like recursion can be applied to trees, it can be applied to backtracking. Well, yes, no one is born knowing those concepts, you'll have to learn them. But if you have a very strong fundamental understanding of decision trees, you can solve a wide variety of problems, from binary trees, backtracking problems, combinatorics, dynamic programming, and sometimes even graph problems. If you've gone through the Leetcode 150 list or roadmap and watched my videos, you've probably got tired of me talking about decision trees. Decision tree, decision tree, decision tree. But that's because they are such an easy way for us humans to understand the intuition of complex algorithms. Graphs are a massive topic. It's literally a sub-branch of mathematics. That's why some of the craziest problems you might have seen are graph problems. But at the heart of graph problems are two relatively simple algorithms, DFS and BFS. You probably first learned about these algorithms with binary trees, because trees are just a special type of graph. But I really can't overstate how important these two algorithms are. You should definitely be able to apply these two on both matrix graphs as well as adjacency lists. Because even though you may be implementing the same algorithm, depending on the structure of the graph, the code can be quite different. But again, don't just get surface level knowledge. I would recommend you to really understand them. Like, you should be able to tell me what would go wrong if I removed any of these lines of code. Without this, we might get an index out of bounds error. Without this one, we might get stuck in an infinite loop. Without this one, we might overcount the solution. I know some people will say, who cares? This sucks, it's not relevant to my job anyway. And that's a fair point, but I don't think it's bad to be able to deeply understand a pretty fundamental algorithm like depth first search. The forbidden jutsu of the algorithms world is definitely the hash map. Whether you're using it to count the occurrences of characters in a string or using it to build an adjacency list for graph problems, it's almost certainly going to be useful in your interviews. There's not much to talk about because thankfully hash maps are pretty easy to use, but if you're struggling to optimize your solution, the first question you should ask yourself is, would a hash map be helpful here? Heaps are also pretty simple. They have a sorted property either as a minimum heap or a maximum heap. They support log n time insertions, log n time removals of either the minimum or the maximum element, constant lookup time, and lastly, heapify can transform a set of values into a heap in O of n time. That's relevant because it's more efficient than inserting elements one by one if you're given all the elements up front. We can't end this video without talking about dynamic programming. We all know that it's difficult to learn, but it's not as common as people think it is. I would definitely prioritize it after all of the other concepts I've talked about in this video, but if you are going to learn it, I would mainly focus on the most common and famous dynamic programming problems, like the longest common subsequence problem, the coin chain problem, and several others that are included in the Leetcode 150 list. Yeah, it's theoretically possible you'll get asked a question like cherry pickup 2. Yeah, cherry pickup 2, because the first one wasn't hard enough. But let's be honest, even if you've literally solved this problem before, there's still a high chance you won't be able to solve this in a real interview. But that's all I really wanted to talk about. I see a lot of people nowadays solving hundreds and hundreds of problems, and there's nothing wrong with that, but if your goal is just to prepare for interviews and maximize your chances with the least amount of effort possible, like doing a reasonable amount of preparation, I would highly recommend focusing on the most important concepts that I talked about.
These are the 8 most important patterns for coding interviews, and this is backed by data.
To be fair, yeah. I'm somewhat happy that I actually know
These
like
patterns are
all of them, like
major
in a
categories
sense
of
like
Leetcode problems,
it's not foreign to me anymore.
which work with linear data structures like arrays, linked lists, and strings.
Dude,
And
I
nonlinear,
think I might
which
end my
work with
stream now
nonlinear data
just
structures
because
like
what?
trees and graphs.
What?
In this
I'm kind of tired. I want to lay in my bed while doing it. What, dude? Love you, Leetcode. Dude, I think I might end my stream now just because. What? Oh yeah, how long was it? 2 hours. Yeah, I think this is a good session for today. I will be back later, probably. I just need a break with like, even though it's a break early, I want to take a new break. Since I just took a shower and ate some food. Regardless, thank you for watching. If you did, have fun.